Hey guys, welcome to a quick tutorial on how to set up your Raspberry Pi, Pico, or Arduino. This is going to work for pretty much any microcontroller. Set it up on your breadboard and get a quick project going. Here I have a LED strip plugged up, but I also have some code to make these lights cycle and then stop when you press the button. Kind of a little fun game trying to figure out which color you land on. You could also do it with the strip, of course. And then right here, so there's three projects. This is the LED strip, the light game, and then right here is the power level. And I'm going to go over each one really quick. I'm not really going to do an in-depth tutorial of the circuits, but I will provide videos in the description for each circuit, or at least explain the circuit. I'll provide a video for this one basically, and I'll explain this one. And then this one's going to be pretty much self-explanatory. So I want to try to give everyone credit that helped me put together these projects. So this first project comes from this tutorial from Clicker Team Fusion Developer. Basically, what you do is you take a light here, and then, and correct me in the comments if I'm wrong, because we're all learning together here. I believe this is parallel and not series, so we have each one lined up in a row. And then the power is jumping from, so we got positive from the power rail to the first light, and then the power is going to jump over to the next positive for the next light, positive for the next light, positive for the next light. And you can keep doing this as long as you want. This one currently goes to 9 volts, so if you want to do 12 volts you need to add another light. And then each resistor here is a 220 ohm resistor. And so at each negative end of the light, if you can see that there, on the negative ends of each light, we jump over to the ground. And then the grounds are all wired together back to the start. So basically what this is doing is sort of like a figure 8 motion, or I guess be more like that, around and then back down to the ground. And so with this, this is a really useful project. I like to keep it at the bottom of my breadboard. I'm probably going to put it on a lot of my breadboard projects, just because when you unplug your Pico, they're kind of hard to unplug. There we go. And you want to use battery, and this Pico is supposed to use roughly it's really 3.3 volts, but around 3 volts of power. And you can see there, it powers on immediately. And yeah, we got enough power for the LED strip. But that's a good way to test that you have power and how much power you have. So this one, I believe, is, let's see how this goes. If this is 9, this one fills up around 6 or 7. This one turns on around 4, fills up around 5 or 6. And then this one turns on around 1.5 volts. When you put one battery, you can barely see it on, and then lights up around 2-3 volts. So it's a estimate of power. All right, now on to the second project, the light stopping game, or rather from both rails. So it's powering both sides of the board. And we'll just plug our Pico in. And I've seen other tutorials where they say go ahead and hold down boot select. Don't do that. That's for updating the BIOS. The boot select basically puts it in BIOS and lets you update the BIOS. So I'm going to get recording my screen. I'm sorry I'm not on my main computer right now. Just bear with me. Once you've plugged it in, go ahead and download and then open Thonny. You can just download it, save it into like a little folder called Thonny, run the exe, and you should have something looking like this. Down here at the bottom right though, you'll notice this. Make sure you click on this and then you select the Raspberry Pi. That's going to load the Pi. So go to View and then do Files. That shows the files both on the Pico and on your computer. Okay? Alright, now for the code. I actually just have it saved in Notepad, so I highly recommend you save all of your Python code or whatever language you save it in somewhere in a folder so that you have a repository of all of your code. I'm not going to go over how all the code works. This isn't really a code tutorial. There's tons of tutorials out there for how to program, but I'll go over the things that are essential for this. So some things like pull up or pull down, that's the button, whether you're pulling up or pulling down on the button, pushing up or pushing down. Some other things are all these pins. These are corresponding with the pins on the Pico. At first I was confused. I thought they were corresponding with these silver numbers. They're corresponding with these green GP numbers, pin numbers, I guess. I don't really know a lot about this. I'm kind of just figuring out as I go. I know a lot more about programming than I do all of this stuff. So here's the program. It's going to be in the description, but basically go ahead and just copy paste the code. Imagine this is the code on the website I photobucket or whatever. And then maybe I'll put it on GitHub. And then paste it in here and then run. And then you just press the button and it switches. Of course, that's the easy part. The confusing part is, okay, how do I plug this up? This is so confusing to a first timer. So again, you're gonna just plug in each one to these pins. So as I showed you here earlier, we have all these pins. These pins actually line up to these green numbers on the board. And then you just literally take one wire for each light and wire up each light. So it's not going to work like you do down here. Like this is raw power, so parallel works. Series is going to be the only thing that works with the Pico. Again, correct me in the comments if I'm wrong. I believe that's right. Parallel only works with power. Series, computer. Of course, you can do series and power too, but you know, trying to make a distinction here. But yeah, so if I unplug green here, because green is on, green goes off. And so that's kind of how I have it organized, is just each color for each light here. And it's that simple. So I have green, it doesn't matter the color, again, they're all wired the same way, each light. So you could wire these in a row, in a circle, however you want to do it, like that old school arcade game where you try to stop it on the right light. But so yeah, it's just power to positive, and then the negative has the resistors going into the ground terminal. And then over here, so we have, see, button on pin 15. Pin 15's at the very bottom here on the other side. So when you line it up with the Pico, there's pin 15. So you just plug pin 15 in. So like if I unplug this, it should not work. Nope, does not work. If I plug 15 in, there it goes, it works now. And it's really that simple. Just come up with an idea, plug the wire into it, come up with another idea, plug the wire into it. The coding is really the complicated part, trying to get a lot of components, like trying to run these two projects together. You would have to like merge your code, obviously. But it's really simple to get started like this. I also have a script that oscillates lights. That's kind of funny. I didn't think this white one's not supposed to be on, not with the code anyways, but it's still on. If I soft reboot it, it should turn off. But I'll also include the code for this oscillating light. So if you just want to plug in two, and it's just a script that just oscillates between two lights. So yeah, an even simpler way to get started here. And if you need to reboot it, all you do is just unplug it and plug it back in. That's how you reboot it. It's that easy. Don't be afraid to unplug it and replug it in. The only time you should be is when you're updating the BIOS. Do not unplug it when you're updating the BIOS, or you will brick it. And if your power goes out while you're updating the BIOS, you'll probably brick it. But then again, these things update very fast because they're so small, so you shouldn't brick it. Very low chance of your power going out while you're doing that. And there we go. I'm glad we kind of had a real life bug for me to show you. The white light was on from the old code, and I switched the code and the white light wouldn't turn off, so I just rebooted it. Now the white light is off. Alright, so I'm actually just going to include this entire little repo I made here and got myself started with. But I'm going to go ahead and show you guys the last one here. I have a base script which just, well, I'll go ahead and show you. It lights it up and then lets you select different colors on the LED. So I'm going to paste it in. I'm going to click stop. Oh yeah, I didn't mention this earlier. Make sure you click stop and start if you've never programmed before. This is how you program me. Stop the IDE, start the IDE. All right, awesome. So now this is on, and if I press this button here, Cool, right? We're changing colors now. Right? If I press it again, it should stop. Kind of the same sort of game we got going here. So I need to do something about this button debounce. It's really bad. Like, doesn't respond right. But yeah. And then this is the LED strip multicolor code. So this code just basically makes it light up multicolor. And if we press stop, it will stop cycling. And if we press the button, it will start cycling again. And you can control the speed of this. So if we stop it and we go to speed and we set this to 50 and we start it, ooh, we're at a club. And fun fact, I actually did use ChatGPT to code basically all of this. I know that's not really what most people are going to be, but I'm going to be honest with you. Most people aren't going to tell you they're using ChatGPT. They're going to lie. The future is writing code with AI. I hate to break it to anyone that wants to argue with me, but code has been written by AI for nearly a decade now. Most people just didn't know about it till ChatGPT made it public. But even years before ChatGPT made ChatGPT public, or OpenAI made ChatGPT public, there was well-known knowledge that AI existed and was writing code. But yeah, so if you want to use AI, use AI. If you're a dork and you want to do this math, sit there all day and do this in your brain like I used to, go ahead. I really don't care what you do. But yeah, so the LED strip, to do the pinout on it, it's really simple. You don't even need to use a resistor, because I think the, oops, I farted. I think the LED strip or the Pico itself counts as ground, since it's already grounded. Correct me in the comments if I'm wrong, but yeah, that's basically that. Thank you guys for watching. That's how you plug in your Pico, encode it, and do a bunch of fun things. See you guys next time.
Thanks for watching this video, guys. If you liked it, hit the like button. If you disliked it, hit the dislike button. Please subscribe and hit the bell icon so you don't miss any more future videos.